Good morning, everyone. What a wonderful year to start today with very knowledgeable session that we have on electrical safety in hospitals. So today, the 7th of January 2023, the first webinar by CAPE and NFE. So the reason that we wanted to start today's webinar towards focusing more on hospitals, there is improper electrical system, poor planning, non-compliance to electrical standards, and poor quality installations. So today we need to understand what is causing these electrical short circuits in hospital, especially on the equipment. So there are over 120 people who have died till August 2020, and more than 140 reported incidents in the hospital installations. So today, Mr. Gopakumar going to highlight more on the reasons why this is occurring quite often in hospitals. So with me, I have very distinguished guest, Dr. Lalit Joseph, who's the General Secretary of CAO and also the Quality Head of CMC. And also we have our colleague, Amaya Shaji. So I would like to introduce NFE, National Federation of Engineers, very focused towards electrical safety. The first time in the country, we formed an association for electrical safety. NFE stands for National Federation of Engineers for Electrical Safety. So we are going to kick off on 26th of January, enrolling the membership, and we are going to come out with what is our agenda, the vision and mission of NFE, and what are the areas that we are going to work, and how we will be complementing the government of India or to the nation development through NFE. So Mr. Gopakumar is the president-elect of NFE. I'm sure that everybody will be quite interested to know more, and we will be coming back to you soon with more details. And this webinar is sponsored by CAPE. Most of you know that CAPE has been the inspiration in doing last 22 webinars in the year 2022. Over 19,000 people attended. Myself, Dominic, been in the fire industry for quite some time and founded many associations and this thing. So NFE is the new baby, and also we have started Indian Society for Brave Hearts, identifying the people who sacrifice their life for saving others. So this is something that new coming out in 2023. I have a very distinguished guest today, Dr. Lalit Joseph, who is the Quality Head of CMC and General Secretary of CAO. Most of you would have heard about her. She's a mechanical engineer by profession and is the quality manager and accreditation coordinator for CMC Vellore, which is the largest in the country to be accredited by the NABH. She has written many books and published articles, member of NABCH and committee member of developing guidelines to develop guidelines for NABH standards, a joint initiative of NABH and World Bank. She was involved in overseeing the implementation of QMS in selected government hospital of Karnataka through consortium of accredited healthcare organization called CAO as a part of World Bank funded project and part of the task force of Karnataka Knowledge Commission implementation and procedural costing. She developed the basic and advanced certified professionals for quality implementation in hospital program for CAO, which are well sought after, and also 7 one-day programs in CAO. She's a passionate teacher and a trainer and involved in training quality implementation across the country through NABH CAO, AHPA, and also the faculty of many hospital administration program. She is the principal assessor of NABH and trainer for NABH. She always inspires me, the way she presented, the way she put it across straight on the face. And I'm so proud that we have today as a opening remark. She'll be doing it. Along with me, I have another well-known face, an international speaker, Mr. Gopakumar, who is the managing director of Cape Electric and president-elect of National Federation for Engineers of Electrical Safety. He's having more than 27 years of experience in electrical safety, lightning protection, and EMI and EMC. He has carried out over 100 site studies on failures analysis of electronic equipment and hundreds of electrical accident analysis, including various fire accidents from electricity. He conducted more than 1,000 training in various countries on the subject of his expertise. He has published articles about safety in various magazines and the book called Missing Link, which is now in great demand. As he said, he is an active member of working group in IEC and BIS and NEC. He is now today is in Delhi. He was part of the in BIS Founders Day yesterday. Yesterday also, the new NEC standard was released, and he played a major role in the preparation of the codes. With me, I have my colleague Ameya Shaji, who's a biomedical engineer with 6 years experience in the healthcare industry, familiar with working environment of hospital across Kerala, worked along with doctors of most critical as well as sensitive parts of hospital, assisting them in providing support during various medical activity. Currently, she's working for CAPE in the region of Kerala. I wish all the best to Ameya, and I would now look forward to hear from our keynote address, Dr. Lalit Joseph. And I'm also thankful to her for partnering CAO with NFE for this webinar. Over to Madam.
Thank you very much, and very happy New Year, everybody. Thanks for that round of introduction, Dominic. It's indeed a very proud moment for us. We are starting our webinar series with our new partner, National Federation of Engineers for Electrical Safety. Safety is part of the DNA of CAO. And I thought I'd use this opportunity to introduce CAO to our audience and thereafter talk about the importance of electrical safety and how to ensure electrical safety in hospitals. I'm extremely happy that you've chosen this theme for the first webinar that you're hosting, and must acknowledge and appreciate you. I would certainly like to appreciate the efforts taken by your organization towards, taking this up as a challenge. This is the need of the hour, and I'm sure all of us agree with the number of registrations that Dominic was talking about. It is quite evident that electrical safety is the need of the hour. So before I begin, I would request the CAO Secretariat to put up the CAO anthem. That is just to tell you what we do at CAO and how this is very much important for us. Over to you, Meenakshi.
Of healthcare delivery and patient safety. We have a noble drive.
Hand in hand, step by step, we will try
to march ahead together, shining future with safe and quality healthcare. We are our skills, spreading the message of quality health care for safer patient care, a better nation.
We have a goal,
We have a goal,
a noble drive.
noble drive. Hand in hand, step by step, we will thrive to march ahead together for a bright and shiny future with patient safety and quality health care. We are AHO Kaho, your healthcare companion, standing right by your side.
Sorry about that buffering, and I'm sure our team will share the Kaho anthem to you through the chat. And that's Kaho for you. Kaho, the consortium of accredited healthcare organizations in India. We are established to promote quality, patient safety, and accreditation in this country. Patient safety is part of the DNA of Kaho, and I would encourage all of you to join us in this journey. And I'm extremely proud and privileged to be part of this association, National Federation of Engineers for Electrical Safety. Because as I mentioned earlier, this is the need of the hour. Most often we talk about fire safety, the fire accidents that happen. In healthcare, we are all aware of the number of hospital fire that happened in the last year. More than 200 people have lost their lives, patients, healthcare workers also included in the list. And during COVID, we saw the magnitude of the hospital fires that happened. Now, all this, we talk about fires, but the major reason for this often would be the electrical aspects. They are all predominantly 90% are due to electrical fires. So what have we done towards ensuring electrical safety in hospitals? This is an area that is not talked about much in healthcare. And, as we construct hospitals, though we know these are areas to look into, we often ignore them, or we don't have the expertise, or we don't have the know-how as to what to look out for. So that is why Kaho thought it's extremely important that we associate ourselves with subject matter experts to learn from them, because the healthcare industry today needs the expertise of people from these specific domains so that we learn and we don't make the same mistakes as we correct our systems. So electrical hazards are more common than what we realize. So planning a hospital, to ensure electrical safety, while we are planning a hospital, it is extremely important that we ensure electrical safety, and not just planning. While we are renovating or while we are working in our own system, we can spend some time, efforts into looking at the electrical safety and making sure that we are compliant. And what I understand is electrical safety is a topic that needs to be talked. We are somehow reluctant to talk about electrical safety, and we think that that is for electrical engineers. And what I have noticed as part of my accreditation career is that in the last 13 years, the hospitals that I have visited most often have engineers who are probably from the civil or mechanical engineering background, predominantly diploma engineers, and there are people as consultants helping them from probably the corporates or otherwise. And you have electricians rather, working under them, managing the systems. So the expertise is very limited to day-to-day maintenance of the existing facility. People don't spend resources on looking at the safety of the electrical installations that probably were put in place 20 years, 30 years hence. And with added equipment, it is, when we start a hospital, it's probably just 20%, 30% occupancy. And as we grow, we keep adding equipment to the load. And at that time, we don't plan properly. We think the existing load will take the need of the other load that we are adding. So it is not designed properly. And from the existing load, it is all taken, not in proper manner, not using proper contractors also. So the safety of these systems, they are never ascertained. And we don't strictly carry out electrical safety audits in our installations, in our setup. So those are becoming almost like norms that we have to do them properly in order to prevent fire accidents from happening or losing very expensive equipment. We notice that there is downtime, and when we look at the downtime of the equipment, it is often related to improper power supply, not connected properly to the UPS, or there is a problem with, even using extension cords. We don't use proper extension cords. And we are also compromising on the safety of healthcare workers and the patients, by not using isolation transformers in wet areas like our ICUs or theater complexes. So we don't know them. That's the problem. Once we know, I'm sure we'll be able to rectify all that. So that is why KAHO is very keen to take this educational drive across the country to make sure that our engineers, our administrators, our managers, our doctors and nurses are equally aware of the problems with electrical safety in our hospitals. So that is becoming like, it is, I think it is more important than just talking about outright patient safety with wrong patient getting operated, which are probably once in 10 years that we have one. But electrical safety, fire safety related issues are kind of becoming inherent to our system today. So that is something that we have to educate ourselves to. So I'm extremely happy that we have tied up with NFE to take this journey forward, because only when people with the right passion come together, we'll be able to address the nation, because this is a national initiative. And this is not something that is just limited to certain hospitals or certain groups of people. It is from the doorman to the chairman that everybody needs to know the safety aspects linked to electrical safety, by which we can have very safe hospital setup. And I'm very thankful that Mr. Gopakumar, Dominic, and all others who are in these organizations are as passionate or even more than all of us have. So I strongly believe, and KAHO strongly believes, it is the love for individuals, it is the love for professionals that can actually have the quality ecosystem and patient safety ecosystem developed in our country. And we are extremely happy and proud that we have partnered with people who are much more passionate than us in their subject areas. So thank you very much for giving us this opportunity. And we look forward to many, many more educational drives through you, and very happy to have partnered with you. Best wishes to you. Our support is always with you. Thank you so much, and Happy New Year to all the participants who are here. Thank you, Dominic.
Yeah, thank you, Dr. Lalit Joseph. Wonderful message. Safety for all. Safety is the need of the hour. Safety should be a way of life. So safety is not meant only for certain people. It is for everyone, whether you're at home, whether you're in office, whether any establishment, safety need to be practiced. I would like to welcome our speaker for the day, Mr. Gopakumar, the international speaker, to talk on the subject of today. Thank you. And this is the first part. I would also remind you that while he was presenting, please avoid posting question on the chat box. There is a Q&A box available down, and I would request every participant to post a question only in Q&A, because we will not be able to record the question which comes on the chat. And kindly do not promote any product or your marketing on the chat box. Please refrain in posting your experience or contact numbers, because this is by the NFE, and it's NFE need to known by everyone. So we'll be keep posting on the chat box more about our association and also about the KAHO partnership. And in the first part, we'll be coming back on the 21st, and the second part will be taken up. So over to Gopakumar. Welcome, sir.
Thank you very much, Dominic. Good morning to everybody, and Happy New Year 2023. Today, or this year, this is our first webinar of the year. We are starting with one of the most important subject, electricity and safety in hospitals. As usual, this time we have more than 350 participants watching us online, plus through several social medias are extra. So without spending much time, let me start the presentation. Now, for all your information, Bureau of Indian Standards had published the National Electrical Code. I will go through the National Electrical Code after some time so that you will be able to understand. Now, for all Indian citizens, you can download the standard free of cost from the website. You can purchase it at free of cost from website. It's a 700 to 800 page document, which is one of the chapter, section 3, part 3, section 9 is talking about medical locations. I explained how this is going to work. Now, to the subject, first is we will have a small overview of the current scenario of electrical safety in hospitals. Sometime if we read the newspapers, we get a feeling that, hospitals and accidents. I'm just showing some of the examples of the accidents last 2 years. People are dying. There is no difference between state to state. It is happening all over the country. This one, Amri Hospital, one of the biggest, 89 people. This is old, 2011. Otherwise, if we look, so many accidents are happening. And in media, please understand that only the serious ones, or where people lost life, or very critical things are only reported. This also means that there are hundreds of accidents happening, which is not a major one, but some small burnings and things like that. So if we look at the size of the hospitals, even starting from clinics up to the largest ones, the accidents are happening, irrespective of whether it is a reputed hospital or less reputed hospital or so on. This video I always used to show. So we have to make our hospitals free from such accidents. Now, if we look at the number of accidents, or from the reported ones from the media, Amaya made a good job. She was going through all the news and she was trying to find out some of the accidents. During 2004 to 2010, there were about 22 accidents. Out of that, you can find out this is the global reported news, and there were some reports as well, and the maximum are in India. 2011 and 2012, out of 29 accidents, you can see majority are in India. And sometimes if we look at the recent location of fire, air conditioners, it gives an impression that these air conditioners are meant to create fire. So many accidents due to air conditioner. And now the data from 2013 for 6 months, again, majority of the accidents, if we look globally, we are having much more accident. One of the data shows about 58 or 60% of the total number of accidents are happening in India, in comparison, out of 100 in the global scenario. So our number of accidents are absolutely extremely high. Now, I would like to invite our speaker, Miss Amaya, for a short explanation about the medical location, the different kind of equipment in the medical location, and the type of accidents which is happening on a daily basis, so that are the improvements required, so that you will be able to understand a little bit more about the medical location. Over to you, Amaya. You have to share the screen. Yes, perfect.
Okay, so good morning, everyone, and very happy New Year to all of you. So I'll be talking about how electrical safety can be done in hospitals. So as you know, hospital can be said to be a hub of electrical installations, right? So many equipments are present, and the number and the type of the equipment would depend upon the area where it is used or its function. So it can be a small patient monitor, which is used to monitor the vitals of a patient, to an X-ray machine or a CT machine. So it can be a bigger machine also. So all of these, it requires an electrical connection to work, right? So that means the staff, patient, the doctors, or everyone in the vicinity of the machines or the electrical connection, they are in constant contact with an energized equipment or a conductor. So if it's not properly handled, it can be really dangerous or fatal to any or all of them in case an accident happens. So these dangerous situations, it can be, it can be due to a sheer negligence. So for example, it can be due to the plugging in of an equipment with a damaged connector or a frayed wire, or the plugging in of a equipment or a connector without a third pin or the earthing pin. So all of these will result in no earth situation. So that means some shock can happen. Or generally, it can be due to unsafe medical practices by the staff or doctors or whoever is present in the hospital. Like it can be plugging in with wet hands or pulling the plug by the cord. It is seen in, especially in ICUs in the hospital. The plug would be at a distance, and the nurses or staff, they'll pull the plug by the cord. And what happens then? A wear and tear happens. Or connecting multiple equipments to an extension cord. So remember, sometimes this extension box would also be locally made one, not a standard one, or not up to the standards which has to be used without the fuse and all. So what happens is that it is getting overloaded, right? So at that time, some short circuit or any arc, anything can happen. It is, the probability of an electrical hazard to happen at that time, it is very high. Or it can be due to a fault, connecting a faulty equipment. The faulty equipment can be connected to the electrical connection, or it can be connected to a patient also. In both conditions, the patient safety is a problem. So what happens when all these things are happening? So what is some electrical hazards? A common electrical hazards happen when all of these practices are done. The common ones are, number one is electric shock. Everybody will be familiar with that. Second one can be an electric short circuit. Then there can be an arc between the plug and the socket, or there can be a blast of an equipment. Or finally, it can lead to fire accidents and explosion in a particular area or all across the hospital. So the most common one is said to be an electric shock. So it's nothing but an unwanted response to the current by a human body. So when a patient or a staff is getting shocked, it will initially cause a tingling of nerves, So then with time, it will start hitting the tissues. Then again, finally, it would cause the tissue damage and burn the tissue. So what happens is that it will actually lead to a burn or damage to the patient or a staff. So there are mainly two types of shocks in the medical location. So one is a macro shock and the second is a micro shock. So these two shocks are commonly found in medical location. Macro shock is the common type of shock where the current takes a path other than the heart. So relatively, it is less dangerous to the patient. It is less dangerous it doesn't mean that it is not dangerous. It is less dangerous because it can cause burns. The most dangerous one is the microshock, which is in where the current will directly pass through the heart. So when current directly pass through the heart means it will cause the heart to go into fibrillation mode. So fibrillation mode means the beating of the heart would be affected. And finally, it might lead to stopping. The heart will stop to pump the blood and it can result in the death of the patient. And another common electrical hazard is electrical short circuit. So it can be very dangerous. So in a smaller level, it can cause an equipment failure or a blast. So it will be, constricted to a particular area only. But at a bigger level, this can lead to a ignition of a fire, or it can turn an area into fire hazard. So the most common areas where the short circuits are found in a hospital, according to a survey, is that number one is an air conditioning unit, like the survey said, and wherever the air conditioning unit is there, the split ACs. The second thing is an X-ray room. Third thing is an incubator. Incubator short circuits are very dangerous because it is related to the neonates, the newborns. So it is very sensitive and it can result in the death of neonates also. Then comes pediatric ICUs. Remember, all ICUs, there is chance for short circuit, but pediatric ICU, the sensitive equipment are much more. So that is why it is more mentioned in the list. Then it can be any ward, children's ward, dialysis ward, or just a pre-op or post-op ward. Then comes the OT. Operation theater also very small to very high-end equipments are used. And multiple equipments would be connected at the same time to a same source. So at that point of time also, short circuit to happen is very high. And then comes the biomedical storage unit, where the repairs of the biomedical equipment, faulty equipment takes place. So during the repair also, there is a chance for short circuit and it can turn into other hazards. So these are some of the examples of short circuit that turned into a fire accident in the hospitals of India. So all of these are mentioned in the news, and you can see that in every hospital, that whole area has been turned into, ashes. So lots of losses are there, lots of equipments, even patient death also has happened. And in the picture on the right, you can see it's a newborn unit. So death of babies have happened. So it is a very serious case actually. So it can happen anywhere, but all these areas are places where short circuits are more happening. So this is a statistic of electrical fire accidents in India. So from 2010 to 2019, there were 33 major fire accidents. That is major. The majorly reported fire accidents in India. And out of that, 78% were due to electrical problems. And in that electrical problems, the air conditioning unit, it was a main cause. And from 2020 to 2022, the COVID time, the number of deaths in fire accidents, it was about 122. 122 deaths had happened. So why fire happens? Fire accidents occur in a hospital. So the answer is the presence of a fire triangle. So the hospital is having an ignition energy source, a fuel, and an oxidizer. So the presence of all of these, it will turn a small short circuit into a bigger fire accident if not properly handled. In case, let's take an example of an OT. There is an equipment called a diathermy or a cautery machine. It is a very sensitive machine, and most of the shocks in an OT comes from that machine. It is used for this cutting or coagulation of tissues during a surgery. Or it can be a drill, which is used to cut the bones or drill the bones. or it can be a laser equipment. It acts as an ignition source. Along with this, OT is filled with alcohol prep solutions. There is surgical drapes, there is hand sanitizer, there is the presence of spirit. So the ignition source and this fuel, when combined in a presence of an oxygen-rich environment where this anesthesia machine or the ventilator machine is working, it will turn a small short circuit into a very big electrical accident like electrical fire. So in OT, that is the case. In case of other areas, it can be any equipment. A short circuit from a smaller equipment in presence of just a hand sanitizer, in presence of a ventilator, an oxygen-rich environment, it can turn into a bigger electrical fire. So let's talk about some common electrical issues found on a daily basis in every hospital. So a staff or a biomedical engineer might be getting a shock from an equipment. So we would just think that is very normal and we might just ignore it. So what we have to think is that it is due to an earthing issue. We'll think it is normal because it is found everywhere and we'll ignore it. But we should not. That is not supposed to happen. That electrical equipment has to work properly without shocks to any of the staff or biomedical engineer. The next thing that we find is that we might find some insulation of the wire. It tends to be sticky or hot at some point of time. So what happens is that it might be due to an overcurrent issue. We should not ignore it. We should not just leave it just like that. We have to check the electrical connection there. The next thing is that we might have noticed some constant failure of an equipment at a particular place or a particular area. Or particular equipment may be showing some wrong readings in a particular area. Why that happens is that it might be due to multiple electrical issues. Sometimes we'll ignore it because when we connect it to a different place, it will work properly. We should not ignore that previously that machine has shown some wrong values or it was not working properly. We have to check the machine as well as the electrical connections there. Then there would be some unwanted activities happening when an equipment is connected. Like maybe if we have connected an equipment, the lights would start blinking in an OT. Maybe if we connect a cautery machine, the OT lights would blink. Or some other equipment might, show some blinking or switch off. Or even in case of an ultrasound machine, some noise can be found. We'll think that it is due to earthing. It is not supposed to happen because we are connecting a 3-pin cord to the plug socket, right? So if earthing is not proper, all of these things will happen. So all of these are electrical issues and we'll think that it is a common problem. We'll just we'll just ignore it or we'll connect it to a different place and check. That is not the reason. It is an electrical issue. And especially in case of an X-ray machine, the common thing is that when we buy an X-ray machine, the company people, they'll advise us to, put a different or separate earthing other than the hospital earthing. We are not supposed to do that. If we do it, there will be a potential difference actually between the earth of the X-ray machine and the hospital earthing. So all of these things are some common problems that can lead to a electrical hazard at some point in the future. Not right now. It might lead into an electrical hazard at some point. So the question is, why electrical safety is a necessity in a hospital? Answer, the reason number 1, the patient may not be in a condition to react normally to the effects of the hazards. 1, the patient, the type of the patient. Patient can be an unconscious patient. The patient can be an unresponsive patient. So it will depend upon whether we'll be able to move the patient from one location to other if a hazard is happening. We cannot wait for the hazard. We cannot wait for the hazard to, go away to move the patient, right? We'll have to move the patient then and there. And if the patient is connected to too many life-saving critical equipments means what? Again, it will be very difficult to move the patients. And if we are short-staffed, there will be no people to move. And the condition of the affected environment also will, for moving the patient, it will be very difficult. Like how severe the hazard has affected the patient environment, whether the equipment that is connected to the patient is malfunctioning or caught on fire or is short circuiting. So this is directly putting the patient in the harm's way. So in that case, if something is going wrong, means the death of the patient is inevitable at that case. So all of this has to be avoided. So to avoid or to bring safety to the patient, we'll have to provide electrical safe environment for the equipment, for the patient, for the staff, whoever is working in the vicinity. And the reason number 2 is that some medical equipments are in direct contact with critical organs, bypassing the skin, like using defibrillator. We are connecting, directly applying defibrillator to a patient. So at that time, if not properly charged, means a burn can happen. So using cautery machines, we are actually cutting the tissue of the patients during a surgery. So this is a very important machine, and most of the shocks in an OT is from this machine. It can be to a staff, it can be to a patient. So this one is very sensitive, and this one has to be properly handled. If no grounding is there, means surely shock will be there. And another one is an intracardiac defib paddle. So it is directly touching the heart. So the patient is in direct contact with the equipment which is energized. So the possibility if something is going wrong, if an electrical anomaly is coming, for all of these patients, when they are connected to all these machines, if an electrical anomaly is coming, it can lead to their, harm to their lives. Their life is in danger. So when electrical or energized conductor or an electrical equipment is directly in contact with a human skin, bypassing the skin, so all of these are the psychological effects that can be present. The patient can get burns, and it will depend upon the type of the equipment and the intensity of the current. They can get muscle cramps. They won't be able to let go of that wire or whatever metal handle they are, which is in their hand, live object that they are holding, they won't be able to let go. And this can lead to a respiratory arrest, which is nothing but they won't be able to breathe. Their lungs would stop breathing, and which in turn will result into the fibrillation of the heart, which results in irregular rhythm. And that can cause a cardiac arrest or stop the heart from pumping the blood to the body. So this is very dangerous. So all of the equipments have to be properly handled and properly maintained. Then only we can ensure that patient is safe, even from a smaller burn or which can lead to a death. All of these will come under the electrical hazard, and we have to prevent all of these from happening in a hospital. So all of these are examples of electrocautery burns. That is, during surgery, due to some electrical anomaly, the electrode which were placed on the patient body has resulted in burns in most of the cases. And all of these cases are from India, and all of them were a result. During the surgery, all of these cases were during surgeries, and it has resulted in burns, and starting from a smaller burn to a 3rd-degree burn. Reason number 4 is electrical equipment. It may be used for a support or to substitute a vital body function. And if a breakdown happens during that time, when the equipment is working or is being functioned, it can cause a dangerous situation, especially in case of dialysis or ventilator machine. Because dialysis machine, the blood purification is done, ventilator, breathing is done. What happens when both of these machines shut down when used on a patient? The patient it will be harmful to the patient. It would result in patient death or patient being in a very serious condition unless they are not transported to another place or another machine. So if it's one equipment is becoming faulty, it is okay. What happens when an area or a whole ward is becoming faulty. In that case, there is no other area to transport them. So when a whole dialysis ward is becoming, some electrical anomaly is happening in a whole dialysis ward, there is no chance for transferring or transporting the patients at all. So at that case, the life support of the patient is stopped. So it can result in a very dangerous situation, and it can result in death also. And in India, deaths have happened from electrical anomaly in dialysis ward and ventilators during when both of these machines were functioning. Due to some electrical short circuit, both the machines stopped. The patients who were on it were put in a very serious condition, and later on the patients, they passed away. So this is very dangerous situation, and it should be avoided, because all of these medical equipments, they are in areas where special treatment has to be done, like ICU, CCU, MICU, NICU, or it can be an operation theater, or it can be a cath lab. So all of these areas, they are rich in equipment with conductive metal parts. And also due to the presence of ventilators or anesthesia machines, all of these, or the gases, it is very oxygen rich. So a small short circuit can result or can turn into a bigger fire hazard. So on top of that, there is presence of alcohol and another flammable liquids, like it may be a small sanitizer, or there is presence of spirit everywhere in the hospital, or especially in ICU or OT or cath lab. So if something is happening or electrical anomaly is happening, electrical fire is something that can happen. So we should not actually think that nothing has happened until now, and it might not happen in the future also. We have to prevent all of this from happening at any point of time, not only now, at any point of time. For that, we'll have to mandatorily follow the hospital or medical locations rules and regulations. And electrical safety is very important, and because patients and staff are put in direct danger if not properly maintained, because they are always in contact with the medical equipment. So the proper training and guidance should be given to the staff to properly work the machines, and proper maintenance of the medical equipment has to be done every time, so that no electrical hazard can happen and no patient or no staff is put in a danger where they cannot be rescued. Over to you, sir.
That's a very good, fantastic presentation, Amaya. You have to stop sharing so that I will share my presentation. Fantastic. Very good. Congratulations for the presentation. So now we go to what we can do or what we have to do. All of you are aware that electrical equipment are classified with respect to safety. Electrical equipment are classified into class 1, class 2, and class 3 equipment. Class 1 is an equipment which is having a body which can experience a shock voltage if there is a fault internal. In a medical location, you can see here we have listed out the class 1 medical equipment like hospital bed, bangles, handheld surgical instruments, non-electric wheels, and so many class 1 electrical things are there. There are class 2 equipment as well. In a class 2 equipment, these devices are made in such a way that, or in simple way, we can say that these are 2-pin equipment with 2-pin plug. So that means there is no connection to earth practically required for this equipment, but there are limited application. The last one is class 3 equipment, which is called as SELV, PELV. SELV is used in medical location. These are for high risk areas. These are equipment operating with very low voltage. That means even in case of a fault, the operating voltage is not enough to create a shock to a normal person. We should understand it, a normal person. In the sense, for example, in a normal condition, in a wet area, the shock voltage is something about 25 volt. In a class 3 equipment probably is working at a lesser voltage. So it may not be able to, this device may not create a shock directly to a doctor or a medical professional, but for sure it is a risk for the patient, because for the patient, once when the skin is bypassed, even a very low voltage could create a problem. So like other electrical application, here also for medical locations or medical environment, the class 1 and class 2, class 3 devices are used. They are classified, and the use of these devices are classified into three groups in the sense the group 0, group 1, and group 2 medical location. Group 0 is a medical location in a hospital where the equipment doesn't come in contact with the patient. That is the normal area. Whereas group 1 is an area where part of the equipment comes in contact with patient externally or internally, mostly on the surface of the body. Some biomedical equipment are sometimes connected or used for some kind of checkings and so on. So in a group 1 location, disconnection shall be possible. That means even if the power supply disconnects, there is not a big danger. Some of the examples are, examination room, treatment room, and so on. We have a chart we will show you later. Then the most critical ones are the group 2 medical location, where medical equipment is in direct contact with vital organs. That means the medical equipment or conductive fluids are bypassing the skin. It is in touch with sometime with the heart. Even a very small voltage could be fatal. So with respect to criticality, these three are the groups which is mentioned or which is specified: group 0, group 1, and group 2 location. Now, in order to get safety for medical location, it is not one subject, unfortunately. For example, if we take care of all the loose wires, if we take care of all the earth wires, if we take care of all the insulation failures, even then that is not actually sufficient for a medical location to have a good electrical installation, a complaint-free or a safe electrical installation. It consists of several subjects. So in NFE, what we are, and another point is, it is not a subject which can be taught like a 2-hour session or 4-hour, 5-hour session. We educate people so that from next day onwards they can work. It is not possible. We are planning to have a special course for the healthcare professionals. That means the electrical or biomedical engineers working in the hospital and in biomedical environment. So we have identified the areas. For example, the subject 1 to be taught is medical electrical equipment and system based on the ISO standards. I have some list I will show you. The number 2 subject is the first subject, medical electrical equipment. There are so many type of equipment available with respect to safety. Each of these equipment is supposed to satisfy certain requirement. So the professional, we will educate them the requirement, the safety requirement of each and every equipment based on the ISO standards, because these equipment are made based on the ISO standards. Number 2, selection, installation, maintenance of medical equipment. Again, the first subject is about the equipment. Number 2 is about its applicability. Number 3 is maintaining safe electrical installation as per the National Electrical Code of India. The NEC 2023 is published yesterday. There was an NEC 2011 as well, but the upgraded version is having some more subjects. And then 4th, the repair and maintenance of medical electrical equipment. So, for example, the subject 1, medical equipment, I am just showing you the type of equipment on the right side and the reference standard. So our training will include safety requirements or educating the biomedical engineer about the safety requirements of these different electro-biomedical equipment. And for example, if we look at the ventilator alone, there are several kind of ventilators available. For example, critical care ventilator, ventilator for emergency medical service, high frequency ventilators, and so on. There are hundreds of type of equipment are there, and each of these equipment have to have its own safety measures inbuilt into it. It is very much necessary for the biomedical engineer to understand the safety requirement of each and every equipment and to work based on that. So our class will be including this particular subject. And the second subject, maintenance of biomedical equipment, I just show you from a standard so that you will be able to understand what I am talking. For example, the standard, which is called as, I'm sure you are able to see my screen. Amaya, can you see the screen?
Yeah.
Sir, I can hear. I can see.
Yeah. Okay. So I'm just showing one example, which is IEC 62353. Medical electrical equipment, recurrent test and test after repair of medical electrical equipment. This standard is explaining you the measures you should take care during recurrent test, means a kind of periodical test. You are using some equipment once in certain time, you are supposed to make some test. And the second part is test after repair of medical equipment. I am just showing some of the requirement. For example, test, the first test, of course, visual verification, the actual test. For example, the clause number 5.3.1 measurements, 5.3.2, the first measurement is done at measuring of protective earth resistance, the most important subject for a class 1 medical equipment. Class 1 medical equipment have got a body, a metal body, which can experience a voltage which can be fatal. So now, if we go through this particular, I will just read out just for your information. For class 1 medical equipment, it shall be demonstrated that the protective earth conductor connects all accessible conductive parts. Very simple to understand. There is a earth terminal on the equipment, and this earth terminal must be connected to all exposed conductive parts of that particular machine. That means the body or different kind of exposed parts. And after repair, before you connect it to the service again, you are supposed to take a measurement of the continuity resistance. Continuity resistance means you should find out the connection is proper and it is strong. Measurement shall be performed using a measuring device able to deliver a current of at least 200 milliampere to 500 milliohm. The open circuit voltage shall be 24 volt. While low current tests up to 1 amperes are recommended, tests using up to 25 amps may be used. See, if you look at a continuity resistance meter of 1 ampere or 25 ampere, these are not small multimeters. These are called as high current micro ohmmeters. Micro ohmmeter means it can measure very, very low resistance connections. Now note, for low resistance values, when a large cross-sectional area and for shorter conductor length are used, higher currents used for continuity test improve the repeatability of the test current. However, testing using higher currents might not detect earth continuity problems caused by oxidation or poor contacts. So basically, this particular standard, this is one of the probably several standards. This standard is explaining how to make a routine test of your biomedical equipment, and after repair, what kind of tests the biomedical engineer should carry out before putting this material or before putting this equipment into service. For example, here, for medical electrical equipment, I'm reading the clause A. For medical electrical equipment or an ME system with a non-detachable power supply cord, the resistance between the protective earth connector and the main plug and protective earthed accessible conductive parts of the ME equipment or ME system shall not exceed 300 milliohm. So this is a requirement for one type of equipment. Similarly, depending upon the type of equipment, so many measurements are carried out, and it is very much mandatory that all these tests must be done. This is, I'm explaining an example of maintaining an equipment. Now let me go to the installation. Installation in the sense, you have a building and you have a wiring starting from the transformer up to your the last socket and device connected to the socket. The installation shall be made based on the National Electrical Code of India. Now it is a legal requirement. You must follow the National Electrical Code of India. Now, the method to understand the requirement of the electrical wiring. For example, I'm just showing you part 1 of the electrical installation. Part 1 is explaining about the requirement of a normal electrical installation. That means every electrical installation, the part 1 of NEC is applicable. And this part 1 is about 380 pages. And this part 1 talks about the methods to protect against electric shock, fire, thermal effect, then over voltage, and so on. Now, and in the group 0 location and normal location, you are supposed to follow the entire part 1. And in case of biomedical equipment, or in case of medical location, like a group 1 or group 2 location, we are supposed to make additional safety measures. And these additional safety measures are explained in the section 9 of the NEC, National Electrical Code. This is part 8. Yeah, this is the part 9. Please note that the requirement in part 9 is, don't think that this is for the entire hospital. No, this is not for the entire hospital. This is only for group 2, group 1, group 2 medical location. So medical location means where a patient is treated. And here, so many requirements. I just show you the requirement of the earthing alone. It is called as supplementary equipotential bonding. Supplementary equipotential bonding means in a medical environment, all the metallic objects in that area must be interconnected in such a way that you can see here supplementary equipotential bonding. In medical location, group 1 and group 2, supplementary equipotential bonding conductors shall be installed and connected to the equipotential bonding bar. So what the standard says is you must interconnect everything together so that within 2 equipment, the resistance of the connection must be lesser than 100 milliohm. This is a technical requirement. Unfortunately, most of the biomedical equipment manufacturers are demanding for the separate earth connection. I would say this is one of the biggest safety hazard, or this is one of the biggest problem in India. So the course for the biomedical engineers, which NFE is planning, consists of all these things. And we are also sure that we can bring international experts for training the Indian engineers. We are also trying to have a kind of an accredited system with which the engineer can be qualified. So about the rules and regulations, we have, these are the codes and rules and regulations for India. For example, IS 732, and the latest one is the National Electrical Code of India, SP 30. Yesterday it is launched. I have put as 2011. Sorry, I could not update it. It is 2023. The most important point which you should understand is the code and practices. The code and the standards are voluntary. And this voluntary document called as the National Electrical Code of India 2023, it becomes a mandatory rule if it is written in a regulation. The regulation, electrical safety, the regulation is called as CEA, Measures Relating to Safety and Electric Supply. Now in the 2022 draft, most probably that regulation will be coming out within a month. Regulation 38, provision for supply and use of electricity in multi-storied buildings more than 15 meters height. The owner or occupier of a multi-storied building shall ensure that electrical installation and works inside the building are carried out and maintained in such a manner as to prevent danger due to shock and fire hazard, and the installation is carried out in accordance with IS 732 and National Electrical Code SP30. So now the regulation is saying that you must follow NEC for all the buildings more than 15 meters. Now the second para says, provided that hospitals and medical establishments shall have safety measures as per National Electrical Code, irrespective of height. This particular requirement in the safety regulation ensure that every electrical installation it must conform to the National Electrical Code of India. Violations, of course, is very heavy. Imprisonments and heavy penalties are there. Now, one of the most confusing subject in the hospital location, earthed and unearthed supply. For general location, a TNS supply must be carried out, which is called as an earthed supply. That means the safety measure is protective equipotential bonding and automatic disconnection of supply. It is a measure. We will educate all these measures to the participants of our biomedical course in detail. Similarly, for Group 2 location, unearthed system, because continuity of supply is necessary. What is missing in almost all our electrical installations are a measure called as protective equipotential bonding, what you are seeing in the picture. For example, sub-panel, motor body, some kind of metallic parts, metal pipe, all these things must be interconnected to a common bus bar. And this is called as earthing, unfortunately, very rarely seen in our nation. And that is the reason for shock and fire hazards. Similarly, we will educate the biomedical engineer about the requirement of inspection and testing. Inspection means there are not one parameter, there are so many parameters which need to be inspected, and each parameter is governed by some clauses of the National Electrical Code. And finally, we are supposed to make a test. We will educate the biomedical engineer how he can carry out the test, starting from continuity up to the last. PAT stands for Portable Appliance Test. We will give you solutions. For example, one of the challenging question which all biomedical engineer ask is neutral to earth voltage is 2 volt, 3 volt, 5 volt. If the voltage is more, the equipment vendor says, I will not connect my equipment because my equipment will be faulty. So such misunderstandings must be removed. And the biomedical equipment, for example, for the special location, we need to go for additional safety measures with additional testing and additional verification. So basically, the course which we are planning will contain not only, it is not about one typical subject, it contains everything, starting with the machine, how a machine is made, what are the safety concepts inbuilt into a machine, biomedical machine, then how you can select it, you can install it, you can maintain it, and you can verify it. Then finally, the requirements of the electrical wiring in your building. All these things will be carried out in the course, and some of the must-have safety measures are mentioned here. But anyway, we will discuss much more on our second part of this program, which is coming on 20th of this month. So with this, I would like to stop my presentation. We can have a question and answer session. But before ending, I would like to tell you that in IEC, International Electrotechnical Commission, where all these standards are made, the Technical Committee 64, MT40 is the Maintenance Team 40. It's a group of experts. I am a member in MT40. This is the global, the team or the working group which is making the standard called as IEC 603647710, requirement for special medical installations. So all the global standards such as the American standard or the European standard or include for Indian standard and the National Electrical Code of India, medical location, actually the origin, the technical requirement starts from or it is drafted or it is made by MT40. So we have good connections with global experts, and I'm sure that we will be able to deliver a high quality training program for the experts. With this, I would like to stop. Thank you very much. And over to you, Mr. Dominic.
Thank you, Maya, and thank you, Gopakumar. And we are now 12. Okay, so we'll take up a few questions and we'll try and conclude by 12:30. And as mentioned, we had a record participants and registration, over 1,250 registration for this first webinar of NFE. Thanks for joining, and thanks for inspiring us with good registration. And I'm sure NFE, the new society which was born in India and being part of National Development Board, you all will join these association and continue in various capacity that you have. You're going to have a various committee within NFE. Your credentials will be fantastic for us to include you in various committee that will be formed. So we will keep you updated on that. So let's go to the question quickly on Mariappan. Whether bed-headed panel having oxygen point electrical socket leads to electrical short circuit. The question is very valid, sir.
Yes, of course. If there is a chance of an arcing, then of course there will be a big issue. But normally there should be a spacing between the oxygen point and the electrical socket. We are not supposed to keep it very closer. Yes, there are not one, but several requirements are there. Probably we will try to touch upon it on next week, the second part of the program.
Now we can have protection on the bed panel itself, sir, for electrical short circuit. The designing of the bed or the bed panel that is coming in. So protective measure can be given. Who manufactures? Is a bed supplier or the bedded panel is a designer who's going to do that?
Mostly the bed supplier, both are there. There are companies, those who are making bed along with this bed and these panels, and there are some companies, those who are making only these panels. Mm-hmm. But the question is whether those equipment are really conforming to the requirement of the standards and whether they are keeping the quality and whether they are, tested as per the standard is a big question to be asked. Amaya, you have any experience in this?
Sir, yes. See, sir, many times in ICUs, the short circuits occur in this bedhead panels only. See, it can be mainly due to this staff, they'll pull the plugs by the cord. So there will be an arcing, and first time they'll pull it will just stretch. Second time, third time, afterwards, some wear and tear will happen to that cord. So that is the main reason this short circuit is happening in a bed panel. And it is there in most of the ICUs, it is there. And in one or two, it's not like in one particular to a hospital. In every hospital, there'll be like at least 12 or 14 beds in an ICU. Out of that 14, at least 1 or 2 will have this problem, short circuiting in a particular bed panel. That problem will be there. And mainly it is due to the small problems like pulling the plugs on such things.
You mean to say that they're not trained how to, plug and unplug and how to handle these equipment?
It is mainly due to the handling only. It is not that they are not trained. Just because they have lots of other works, they'll just, plug. And also near the bed panels, there'll be lots of critical equipments, like let's say a ventilator. All of these will be present near the head of the patient, and the bed panel is on the top of the head, right? So what happens is that there won't be a space to, reach. So that is the main reason they'll pull the plug. So that is why short circuits are happening more in ICUs and near the bed panels.
That's quite a good eye-opener. Best practices, how to plug and unplug while patient is on the bed. Anyway, let's go to Dr. S.P. Anchuri. Also a good question, but I don't know we can answer. He's saying, no doubt electrical installation, proper operations, very important. But many small and medium hospitals, the basement is now converted into lab, testing, even the emergency ward, So functional planning is also important. How NABH is approving it? Your comment, please.
Actually, Mr. Dominic, I am not the person to comment on it. Probably you have more experience in the fire part.
Yeah, I do audit for the hospital. In our NABH, they approve it because NABH very clearly says follow the National Building Code. So if you follow National Building Code, these are not authorized. Basement not supposed to be having any electronic and electrical equipment. We have seen how the Miot Hospital during the flood, 11 people died because the entire genset and everything got flooded, and there is no oxygen for the hospital. So there is no recommendation to build labs or the emergency ward at this thing. We need to bring it to NABH while assess the hospital. How are they approving or renewing the license? So this is a debate that we can have with the AHPA, NABH, and CAO in the later stage. So, Charlie,
one more thing, the basements, mostly it will be converted to a radiology department. So radiology department is like mainly for the ease of access, actually. So there will be bigger machines like an X-ray, MRI, or CT. So it's like very dangerous. And those places, they will have a separate earthing also from the hospital. So all of these things, it will result in a very, dangerous situation.
Yeah, ease of access doesn't mean the compromise on safety. So the question is, are you allowed to operate on a basement with all this equipment? The answer is no. There is no recommendation, nor it is approved. But how NABH is renewing is a question that we can debate with them later. So let's move to the question from Chari. Sir, good to have a webinar. Webinar on commercial electrical safety into the IT company. Yes, it's a good value point, good suggestion for the year 2023. We will definitely come out with best practices in commercial building and IT. So we'll take it up, Mr. Chari, soon. So Nitin, what is the normal acceptable range of leakage voltage between neutral and earth? In India, most of time, these two poles been short and shows zero voltage leakage. Is it a standard practice?
Actually, this is not leakage. In any system, if there is a neutral current, then of course between neutral and earth, there is a voltage built up. And this voltage is due to the neutral current, the current which is flowing through the neutral conductor. I don't know why the medical equipment vendors are always asking for very, very low voltage, such as 1 volt, 0.5 volt, and so on. But if you look at medical location 2, where a medical IT system or medical isolation transformer system is used, which is generally called as medical or OT panel, there are two systems. One is with the distributed neutral, and there is no distributed neutral system as well. So in case of a distributed neutral system with a medical IT, the voltage between neutral and earth can go up to 230 volt. That means your equipment must withstand this 230 volt. Rather than checking this neutral to earth voltage, what we are supposed to do is we should check the equipment, especially the insulation resistance of the equipment, and find out whether all the resistance, the IR value between all the live conductors connected together to the earth is higher than 1 mega ohm. So if that test is carried out, then actually this voltage up to 230 or even higher is absolutely not an issue. It is not because of leakage, it is because of the neutral current flow through a single phase equipment. But Amaya, you can add your experience with biomedical background. Mostly I have seen the biomedical equipment companies are asking 1 volt or...
No, with volt, it doesn't actually, most of the companies actually, they don't actually say, but they'll say about earthing only. Whatever earthing only, they'll, give a suggestion, like they want separate earthing. And with voltage, they don't actually usually say.
Okay, so probably in Kerala, there is no voltage problem, but in some parts of the country, this is also a preferred question. Now, the separate earthing in the sense the equipment vendor will ask for a separate earth pit, a clean earth pit, which is a little bit far away from other dirty things. Is it correct?
Yes.
Yeah, I think this is a common disease in India.
Okay, moving to Nitin's second question, also I felt it's good. There is a device called electrical safety analyzer. However, according to NABH and calibration by third-party company, it is called calibration, which is wrong practice. Not a single MNC such as GE, Siemens, Philips practicing to use electrical safety analyzer. They check with multimeter and close PPM saying electrical safety test done. Even the PPM checklist being filled later instead of during the checking of the machine. I think he's suggesting, is it why they practice outside India, why it is not being practiced in India? Amaya, are you aware of this?
Yes. Not every hospital, but most of the hospitals do purchase this electrical safety analyzer, and they'll conduct the test, and later on they'll fill it. So I have seen this, but it's not practiced in every hospital. Only the corporate ones where at least proper checking or preventive maintenance is done.
So it is not mandatory.
It's not mandatory. It is completely up to the hospital.
Okay. Jatin Panchal is asking, as per NEC 2023, can you please highlight the use of fire survey cable for wiring the fire emergency in hospital? Does it talk about fire survey cable in NEC?
Yes, fire survival cable is required for the emergency supply, not emergency, we call safety service.
Okay.
So for the fire safety service, yes.
Yeah.
But please note that it is not only the fire survival cable, the entire electrical installation must withstand a certain time. That means the clip, clamp, conduit, supports, fixings, lights, junction boxes, and so on.
Okay, moving to Arish, the root cause indicated, the simple checks may avoid large number of electrical unsafe conditions and acts. Why safety audit is not conducted at frequent interval and necessary action taken to repair or replace the faulty equipment? Even necessary action should be taken on concerned person who adopted negative attitude, chalta hai, ho gaya, agle baar dekhenge, all this. So he is saying why in the audit, why that correction is not taking place after the audit.
Actually, there is no qualification criteria for the auditor. So most of the auditors, they do audit as per their experience. For example, in hospitals and, example, I am sitting in a hotel in Delhi. It's a big hotel. And next to me, I have a water heater, the kettle. And the kettle is having a German socket and pushed into an Indian, German plug pushed into an Indian socket. So the earth continuity itself is gone. A similar thing we can see in so many places in hospitals. Imported machine coming with the German plugs put into Indian socket. The auditors are not even capable of noticing this simple mistake. Most of the auditors are recommending in, about 70, 80 audits, which I did in last 3-4 years. Most of the auditors are recommending chemical earth pit. So basically, this shows their, incompetency in doing the job. So that is the reason if NFE can take up this training program, we can bring a lot of professionals to do it proper.
Wonderful. So Uday Batwal, is isolation transformer is good solution for sensitive equipment?
No, isolation transformer, we cannot say in this way. Sensitive equipment, first of all, we should understand that what kind of sensitivity is there or what kind of sensitivity is applicable for the equipment. Does it have communication lines? Does it have sensors and so on? Based on that, we have to select. Isolation transformer for hospital medical location is to ensure that even during the first fault, the supply is not disconnected. Continuity of supply is ensured by medical IT system. Of course, for certain application in industrial cases, medical, the isolation transformers will work. So this is called as safety measure protection against shock by electrical separation. Electrical separation is an accepted safety measure, but we should understand that there are several conditions applicable.
Sir,
Over to you,
Praveen,
Mr. Dominic.
Praveen Chandra is asking, the building less than 15 meter are supposed to follow NEC 2023?
Legally, there is no requirement, but there is one more regulation which I didn't show. This is called as Regulation 12, Sub-Regulation 2. It says all buildings should follow NEC 2023. So it is not like, yes, irrespective of height.
Mm-hmm. So the answer is, irrespective of heights, you must follow NEC 2023.
Exactly.
Are you showing something, Mr. Gopakumar, or some table or something?
No. Okay,
I'll move to Balaji. Good afternoon, team. Which earthing is best? Common earthing or individual earthing or the equipment like X-ray?
I don't know. Probably if the question is about individual earthing, what he meant is separate earth electrode or an earth pit. Please note that this is wrong. So the only good method is interconnection, called as protective equipotential bonding.
Okay.
Over to
Krish, when it comes to IT system earthing, what kind of tests need to be carried out in the initial verification?
I have shown it in the presentation. I don't remember for example, the insulation monitoring devices, its operation need to be checked predominantly. Yeah, that is the one.
Dheeraj he has a question regarding fire due to air conditioning. One slide showed, causes of AC. Please explain.
Sir, maybe you can explain it better.
Yeah. You see, lot of accidents are happening due to, or the fire starts from the air conditioning unit, especially split air conditioning unit or the indoor unit, which is in the protected place. First of all, from this January 1st onwards, every air conditioner sold in India must have an ISI marking. So mandatory marking has been enforced. So all manufacturers should. So non-ISI marked air conditioners cannot be sold in India. And now for ISI marking, there is a series of tests and there is a series of technical requirement. Unfortunately, those technical requirements are not up to date. So these are a little bit old. The next step, BIS, I think, is trying to make to upgrade the air conditioner standard. Basically, the problem is the air conditioners used in India, they are not able to withstand any kind of over voltage, be it temporary or permanent. In case of any kind of transient or in case of any kind of over voltage, the insulation fails and it leads to an insulation degradation, either fault or a short circuit. Now, the second point is, most of the time we use our air conditioner through a stabilizer. Unfortunately, the stabilizer reduces the fault current. Instantaneous tripping current, which is mandatory for short circuit, is bypassed. The instantaneous, the MCBs, which is supposed to trip instantaneously, will not trip because there is a stabilizer which is adding the impedance, reducing the short circuit current, and this lead to fire. So you can have two safety measures. First is, if you are having a stabilizer, either you check the impedance and the fault current at the output of the stabilizer, and if it is not sufficient to trip, then you must disconnect or you must remove the stabilizer from the circuit. Stabilizers are actually a danger. So these two problems together are creating a hazard. Probably, I think slowly we will be able to overcome this problem.
Okay, I'll go to move on to Sambit Pani. Sir, is there any way to measure insulation resistance of a final circuit without disconnecting the load?
That is very difficult because it depends on the type of the load. If you are talking, some equipment, this is possible, but anyway, that is not the recommended practice because your equipment may fail. So the recommended practice is to disconnect the equipment and test.
Atul, what are the checklist points, especially for air conditioning unit?
At the moment, there is nothing like a checklist. It is the responsibility of the manufacturer. He has to test. And once when you buy and install, then before installing the air conditioner, we are supposed to check the short circuit loop and fault loop impedances and then install it. But unfortunately, this is not carried out. Over to you.
Okay, Latumani, good morning. For getting IT system for OT and other special location, is it necessary to separate 11.4 kVA transformer or separate isolation transformer is required?
Yeah, this is actually a separate isolation transformer, and the capacity of the isolation transformer, please note that it is not only the isolation transformer. The isolation transformer should have it has to satisfy certain standards. Unfortunately, that kind of a transformer is not made in India yet. Some manufacturers are still trying. And this system also shall have the insulation monitoring device. So it's actually a total system. The maximum capacity allowed is 10 kVA, and it has to be within 25 meters closer or within 25 meters from the applicable load. That means these are localized isolation transformers for a particular load. It has to be connected to the 230 or 400 volt supply line. Yeah.
Somachandar is asking, what is the minimum protection recommended for medical equipment, especially for critical equipment? Is there any checklist minimum protection required?
Actually, there is nothing called a checklist. That list itself is a big list. So it is not like 3-4 lines you do it and it is safe. It is a big list. Anyway, we will talk about it in the next program.
Okay. Balchandran, thank you. Ali Akbar, are you dealing with any Joint Commission international standard for safety training? Ali Akbar, I don't know from which country. I don't know whether you're from India. You can offline, you can send this to Mr. Gopakumar. We will reply to that. And if you are outside India, we'll be interested to know more about this. So I will move on to the Davies. Nursing staff also need basic electrical safety training, particularly those who are in ICU.
Yes, of course.
Yes, of course.
Do we have any courses that will be conducted to the staff nurses, sir?
No, actually, there are no courses at all. But when an installation is happening in an ICU or OT or certain critical places, usually the biomedical engineer would train, or the personnel from the company would come and train the staff or whoever is present in that vicinity or that area on how to operate on or how to work that equipment. So that is where all the training is happening. And they don't particularly train on the safety measures. They will only train on how to work that equipment. The safety measures come from the biomedical engineers in the hospital.
Okay, moving to anonymous question. What is the effect of harmonic in safety, considering most of the devices in the hospital are non-linear in nature?
You see, with respect to safety, harmonics is a power quality problem. With respect to safety, harmonics will create overcurrent in the conductor. And this overcurrent through the circuit will lead to higher temperature rise, and over a period of time, this creates a problem. The simple safety measure or the simple mandatory safety measure when harmonics is present is, if the harmonics is more than certain percentage, for example, 5%, the supply must be disconnected. So you are not supposed to work in a harmonic environment with more than certain limit. Now, For example, neutral. The neutral current must be measured, and if the neutral current is more than its capacity, the line conductors must be disconnected. This is the very simple, straightforward safety measure required in case of a harmonic environment. Then people will ask, then harmonics are generated from the machine. What do we do? First of all, you should select an equipment which is generating less harmonics. For example, LED lights. In the market, you will get LED lights which is producing less than 5% harmonics, and some of the LED lights, this parameter is not tested, and practically if we test, it's even more than 30%, unbelievable harmonics. So first of all, you should select, you are using a semiconductor based device to save energy, but the problem is harmonics, and you should select the device in such a way that the emission is much lesser. And I think the allowed limit is 3% or 5%. More than that, we are not supposed to connect. Unfortunately, we connect several items together, which is combinedly generating more harmonics. And once when the limit is crossed, we are supposed to filter it out, or we are supposed to electrically isolate the circuit.
Okay, this is to Amaya. Amaya, you talked about the plug. What kind of plugs are supposed to be used on medical equipment in ICUs? IS 21293, IES, IEC 60309. Or is there any special standard altogether?
I think to my knowledge, there is no special standard. It is the normal Indian standard, the plug and socket as per the Indian standard. Here the problem is plug is in with one standard and the socket is in another standard. That is the problem. Both plug and socket must be of the same standard. If you are using German socket everywhere, then the plug also should be German standard. That is more important. But the most important is you are not supposed to use a German socket in India. It should be as per the Indian standard.
And also use a converter which is of approved standard. Like, usually hospitals use this converter.
Yeah, they use 5 amp to 15 amps, like the adapter used. Anyway, Balchandra Loganathan is clarifying that all the radiology departments should be installed below the ground floor.
It's not that it should be installed below the ground floor. It should be at a place where there is an access, to ICU or OT, or it should be at a place where there is accessibility. And it should be at ground level. Basement is something which is underground, and I'm not talking about like it should be. There is nothing like it should be underground. It should be at a place where accessibility is there, near to ICUs, near to OTs, near to wards, and preferably in the ground floor, not below.
Again, Mohammed is asking about what else we can use the basement. Can we do it for dental, OPD, stores, welding and carpentry? But as per the NBC standard, you're not supposed to occupy the basement, which is supposed to be for car park, whatever the purpose it has been approved. Again, it is based on the standard I would recommend. And also the size of the building matters. Dr. Pradeep Sharma, are beds flame-proof and mandatory for patient safety in hospital as NABH accredited? Or beds are flame-proof and mandatory for patient safety in hospital?
The problem doesn't come from the flame-proof bed. The thing is that bed is mounted on a metal part, right? So especially in OTs, it will be a wet area, like fluids will be falling on the floor when surgery is taking place, especially blood and all. So what happens is that extension cords, they use the extension cords on the floor of the OT. So mainly short circuits can happen and fire can happen, and that can affect the patient. So it doesn't mean like with the fireproof bed, accidents can be avoided, because patient would be touching the metal parts of the bed, because it is to move the bed or to rotate or manipulate the bed, it is made of metal only.
Okay, Marutesha, yes, your suggestion to do a webinar on large cinema hall and malls, yes, we will take that as a positive feedback. We will come back to you soon. Dr. Ali Haider, in what time period should internal wiring be checked regularly, sir?
Actually, there is a new standard made, I think in NEC itself, the 2023, the yesterday's published version. There is a table in part 1, section 17. I don't remember the exact period. I think it's 2 years or 5 years. You can refer that. Part 1, section 17, I think annexure C or D.
Hope you got, Dr. Ali. The new standard talks about it. And Anonymous, again, we had come across a situation in a hospital itself that the current flowing in the neutral was almost equal to the full load current. There, the harmonic 2 was towards the higher side. So he says there is an experience. He has an experience on that.
Yes, of course. If there is a single, if all the equipment are connected to one phase, then the neutral current will be equal to the line current. Unbalanced situation.
Somik Manna is asking why isolation transformer is used for medical equipment.
That is to create a separate isolated power source or isolated supply which can continue the supply during the first fault. So even if there is a fault, the protective device need not have to trip. Continuity of supply is ensured by making this method.
Okay, though it is not related to today's subject, Hari Katla is asking, sir, I'm working in a fire and combustion research center. Some of the research equipment getting little bit of shock. For earthquake, what type of earthing mixture will use? So he's asking one suggestion, one doubt.
My God, your shock has nothing to do with the earth pit. If your shock has something to do with a faulty equipment, the insulation must have gone. You should check the insulation resistance of the equipment, and if it, you have to repair it.
Hope Hari Katla, you got the message. Please check the equipment, not the earth. So, Davies, do we use AFDDs in hospitals?
Not yet. Not AFDDs are recommended for in houses or in commercial installation. Basically, in houses for bedrooms, and for commercial installation, if there is an explosive area, then AFDDs can be used. But for medical location, you cannot use it because if it trips, it can lead to other kind of issues. So we should make the installation in such a way that there is no loose contacts.
Okay, Prafulla, what are the equipment? What are the equipments for fire protection electrical panel? Which panels shall be mandatory protected? Let me explain on this. Like Maharashtra and Gujarat is made it mandatory to use fire suppression system and electrical distribution panel. So it's a tubing system. You can use any kind of gas clean agent suppression system. Yes, you need to protect the electrical panel for state like Gujarat and Maharashtra and made it mandatory, and Karnataka soon will have it. So it's a state subject, but protecting electrical distribution panel is necessary through fire suppression system. So why German plugs don't have earthing? Praful is asking.
Oh, no, it is not like that. German plug have earthing, but by construction, it is in a different way. So it won't, if you put it in an Indian socket, the earth connection is not in contact. So it is having earth, but in a different way.
So Nikhil is asking, should the socket be industrial one for machines?
For larger machines, yes, of course, industrial. But for medical, inside the medical rooms and all, industrial may not be practical. But of course, industrial plugs and sockets increases the reliability. But the problem is you cannot pull through the cord, so it won't come out. So then operational difficulties will be there.
Okay, KM New Hospitals, no names here. What is the Indian standard voltage for earth to neutral?
Sir, there is no standard for that. If the neutral is accessible to a person, neutral to earth voltage can go to a maximum of 50 volt in a dry condition. If it's in a wet condition, maximum 25 volt. This is with respect to shock, because neutral is not completely insulated. There are chances that people may touch neutral and they get electrocuted. Other than this requirement, if we don't consider this, neutral to earth voltage, if we only look at the equipment's performance point of view, neutral to earth voltage can be even 230 volt. That means even if you put your line in a single phase equipment, even if you put the line and neutral ulta, the equipment is supposed to work. So I would say 25 volt for wet location, 50 volt for dry location with respect to shock if you are not sure that your neutral is completely isolated. Otherwise, 230 volt.
Okay, hospital use, I think is commenting the hospital use servo stabilizers, sir. Servo stabilizer.
Yes, as I said, every stabilizer is a problem because it is adding a series impedance. As a result of the impedance, the instantaneous, if there is a short circuit or if there is a earth fault of negligible impedance, the current will be lesser. Once when the current is lesser, the protective device takes more time to trip. You can use a stabilizer, but then the protective devices also shall be made for operating in that condition.
So, Chirag, is two questions. What about the inverter AC? Is it inherently safer? Or ICUs or such rooms are considered to be confined space?
Actually, nowadays, the modern inverter ACs, the manufacturers are not recommending stabilizer. Probably they also know that the stabilizer is going to create some trouble. And inverter AC the inverters are able to withstand a higher, the operating voltage range is larger than the earlier ones. So probably stabilizers are not required. Second part of the question, is it inherently safer? Of course, they are not tested as per the latest requirement of IEC standards. They are tested as per the IS standards, where for example, one of the test carried out is 1000 volt permanently between live conductors and earth for 2 seconds. Actually, this test is not sufficient. Instead of 1000 volt, it should be 1480 volt or 1430 volt for 5 seconds. So the test voltage and the duration has to be increased. The second part is voltage impulse test. So the question to be asked is whether your air conditioner you treat as a pluggable equipment or you treat as a permanently connected equipment. If we treat it as a permanently connected equipment, the inverter, every AC must be tested with an impulse voltage of 4 kV. So it must withstand 4 kV surge voltage. If it is a pluggable unit, which generally AC is not considered as a pluggable unit because you always connect it 24/7 into the socket. It's a permanent device. So these tests are not carried out until now, but probably in future these improvements will happen.
His second question is, ICU and other critical room considered as a confined spaces?
Of course.
It is considered.
Yes, it's a.
Okay. Sir, Krish is saying, following up on your answer on his question, IT earthing, how do we test insulation monitoring devices? Would it be self-test by device itself, or would it be only through periodic testing and cross-checking the values of insulation monitoring devices and an IR tester?
Yeah, Mr. Krish, there is a related standard available, and the respective test is also included in the standard. I think 2-3 types of tests are there. I am not sure the exact type of test, but these are already there, documented in the standard, and you should refer those documents.
Okay. Praful, you are asking on the kind of what kind of fire protection. My mail ID is there. You can write to me separately. I will answer to you because I am from the fire background, so I could guide you depending on which state are you. And Balchandar, in clarifying, like linear accelerator, brachytherapy therapy equipment should be installed below the ground floor as per the AERB norms. So it is giving more clarification on use of.
Correct. There are certain equipment which is producing kind of radiation, and those equipment should have the radiation protection as well, so that the radiation is not affecting the patients. But this must be always under the ground floor. Actually, I'm not sure. It can be even on a higher floor. You have to make the environment protected. Amaya, you have any idea? You are on mute.
Amaya.
Same thing only. This linear accelerator and brachytherapy, all those things are not found in every hospital. So that's like very higher, expensive equipment and found in like less number of hospitals. And not everywhere this is under the basement, because there are places like corporate like Aster and all where it is not on a basement floor. They have properly lined the walls, made the environment in such a way that the radiation is limited to that area and it is not going out. So such kind of practices can be used to keep the equipment or install the equipment in the ground floor itself. There is no need for going to the basement floor.
Okay, anonymous attendee, I would have appreciated if you have put your name so that we have a name for anonymous. Anyway, do we have a latest NEC India? How NBC is different from the new NEC code, which is more stringent in this?
It is not like which is more stringent and which is loose. NBC talks about everything related to construction, starting with the civil, cement, steel, structural, the civil design, structural design, fire protection design, the services like plumbing, HVAC, and so many things included in National Building Code. And electrical is a small part included in a building. And if we look at the National Building Code of India, some of the electrical related items which is important for a civil engineer is included. For example, there is a panel room, the size of the panel room, the kind of height required, the kind of space required in the panel room or a transformer station or a DG station, those are included in the National Building Code. Technical requirement of the electrical installation is not included in the National Building Code, whereas National Electrical Code includes all the technical and safety requirements of the electrical installation. In the sense, how you must design an electrical installation to protect from electric shock, protect from fire, protect from overcurrent, overload, and so on. So both are important. The NBC is for the civil engineers and the other engineering fraternity, and the NEC is for the electrical engineer.
Okay, our ICU and enclosed norms are considered confined space. Is any specific safety need to be followed? Yes, of course. You need to have a partitions or material should be fire retardant pacifier. We call it pacifier system that need to be used in the confined spaces. Moving to Nikhil Jain, sir, what question should one ask during inspection to check whether the electrical wire laid is properly chosen? I mean, sufficient without causing an electrical short circuit. So Nikhil Jain is asking what question should we ask during inspection?
Yeah, Mr. Jain, it is not actually one question. It is a practice which has to be followed. Number one, it starts with the proper sizing of the wire, proper derating of the wire. And if you look at the type of the wire, copper wires which is pulled through the conduit, there are two types. One is with the class 2 flexible wire, class 2 copper conductor, and next one is copper conductor class 5, a wire with class 5 copper conductor. We are supposed to use PVC insulated wire with class 2 copper. Class 2 copper is having lesser resistance. But unfortunately, we discussed in several of our programs, the availability of class 2 conductor, copper conductor, is very less in India, mostly class 5, which is not supposed to be used, are only sold in India. Nowadays, anyway, the National Electrical Code included the resistance of the conductor in the part 1, section 17, annexure B. So you should refer that, and whatever the wire which you are using, depending upon its length, the resistance shall be lesser than the recommended resistance. That is the first point. Over to you, Mr. Dominic.
Okay. Again, Anonymous is asking why there is no separate earthing is required for X-ray machine. Kindly explain. Why it is not required? The question is for X-ray machine.
The question, we have to ask a question back. Why it is required?
He's asking
it is actually not required. If it is connected to a separate, okay, why it is required? It is required because of the non-knowledge of the professional who is involved in that particular work, because he don't know how to make a safe installation. So they may ask for separate, which is absolutely wrong.
Okay. I think we have almost done. People are asking, where will I get new NEC? I think people have missed when you said it is freely available in the BIS website. It is available. You need to register and download. So is it available? Yeah, it is free. What I understand from Mr. Gopkumar today, it's freely available.
Yes, it's free. I will post the website link again so that people can download.
So look at the chat box. Yeah, chat box. Mr. Gopkumar is sharing the link to downloads NEC 2023. Meanwhile, I'll take the last question. Krish, when looking at the risk premature collapse of electrical wiring system during fire condition, is there any widespread adoption of appropriate enclosure cable support system in hospital? Enclosure for cable support system in hospital.
Adoption of enclosures for cable support system. Most of the time, the larger cables are installed in enclosed the ducts or metallic ducts only. But with respect to fire point of view, the fire protected ducts, of course, that practice is yet to start. The compartmentization plus fire sealants at each and every compartments are already included. But as we discussed in one of our last program, if you use a fire sealant, the wire, plastic in the wire also should have certain properties to stop fire. Unfortunately, that is yet to be confirmed. It's a time-consuming job. We are progressing step by step. There are so many other things to be taken care before going into the final, very, very small or very, very, all subjects are important, but, very serious points. There are several other points to take care.
So last question today, I think we'll take the two questions. So could you please tell us the difference between IS 732 and NEC 2023?
Both IS 732 and NEC, IS 732 explains about, it is adopted from IEC 60364 up to part 6. That means general electrical installation. Whereas NEC had included part 7 and 8 of 60364. So from NEC, you can find out the safety requirements in the general electrical installation, plus the electrical safety requirement in special installations such as, for example, bathrooms, medical locations, solar PV, and a lot of additional informations are already there, are included in NEC 2023. But anyway, about wiring installation, electrical wiring installation is already included in IS 732. The information is already there in both the document.
Okay, the last question, Prasad Rao Swami. Who is authorized for occupancy certificate with respect to electrical in hospital?
Actually, the classifications are included in NEC. There are the authority who is responsible for fire or fire safety. Let's say, for example, the fire safety department or the municipality or whoever comes, they are the one who are responsible for making the classification of. There are 4 classifications: BD1, BD2, BD3, BD4. So the electrical engineer's job is each of these classification. Let's say, for example, BD4, it requires a special kind of installation. Electrical engineer should look which classification it is there, and appropriate safety measures need to be included. Who classify this is up to the authorities such as municipality.
Okay, Vijay Kumar is asking more about fire retardant coating. You have my mail ID. You can write to me separately. I will give you the details who supplies, who could support you in supplying these coating for cables. So thank you, ladies and gentlemen. We have just crossed 2 minutes more than our time which is given. It's 1:02, the first webinar of the year 2023. Wonderful. Love to see still participants are waiting to understand more question and answer. This recording will be available in our YouTube and our Solve blog. And we'll also be sharing separately to each individuals who are registered, those who missed it or those who attended late. So all will be getting the recorded video of this webinar. And I look forward to see you again for the part 2, what causes electrical fire in hospital, on 21st, the Saturday, for the second part. And also NFE, we will be opening for membership, and I'm sure those who are been participating in our exhibition all will get an invitation to join the NFE. And if there is a specific expertise, or will be welcome to join various committee. So wonderful. Thank you, Gopakumar. Thank you, Maya, for sparing valuable time and sharing your rich knowledge on hospital. So it was wonderful. Wonderful. Thank you, Dr. Lalit Joseph, who gave wisdom and experience to us. And we look forward to associate with CAVO and AHPA, many more medical association in the future. Thank you so much. All of you have a wonderful weekend with family. Stay safe, and we'll come back to you soon on 21st January. Thank you so much.
Thank you. Thank you very much, Dominic. Thanks for all the participants.
And also I want to thank our back-end support, Ms. Lakshmi, who's been most of the Saturday, though we don't work on Saturday, I enforced her to come on Saturdays. And Saturdays being very successful for us because many attendees, once we did on Sunday had the maximum capacity, but I'm sure everybody want to relax on Sunday. So we thought not to have on Sundays, but we may have occasionally. And thank you, Lakshmi, for joining today's webinar, supporting the program. Thank you so much. God bless you all. Bye-bye.